Hello everyone, welcome for joining me. Today we are going to talk about GibbsCAM MTM with machine simulation and how to synchronize turrets with each other, turrets or gangs on tool groups. Let's have a look right away and open a part and jump into it immediately. So here I'm opening a new part. It is a turning part. As you can see, it's a solid. We have also a wireframe geometry. But before we actually talk about the part itself, let's talk about the machine. Let's open up our machine simulation. Here we have our machine. Let's open the door and let's talk about the configuration of the machine real quick. We have an upper turret, we have a lower turret, we have a main spindle on the left, and we have a tailstock on the right hand side. So this is sort of a kind of a typical MTM machine. If we want, we can have a look at what we are machining or trying to talk today about. So let's do machine simulation. And I explain a little bit what's going on inside the machine while we're over here. With the lower turret, we just faced the part, then we drilled a hole and the tailstock came in, supporting our part. Now we are machining with both turrets, doing pinch turning with the upper turret and the lower turret. Simultaneously, then upper turret comes and is doing some finishing on the OD, then the lower turret also joins in, grooving some kind of a V-groove. The upper turret is doing some thread reliefs, things like that. Basically machining the part simultaneously, and this is what MTM is being used for, how to program these type machines in GibbsCAM MTM. And since we're talking about it, MTM stands for multitask machining, which we're doing right here with that machine. A little bit of milling and drilling with the lower turret. Tailstock goes home and we're end of the program, one cycle. Okay, let's close machine simulation and let's talk a little bit about more the part and how do we start and select a machine that we want to program the part in MTM. In this case, it's an Akuma LU4000. This is our document dialog or DCD, where we basically start out and tell the system which machine we are using, what kind of material, what format we are in, either in inch or in metric. Either way is fine. In this case, we are in inch. We give the spindle, the stock sizes and everything, how much machining allowance, the outside diameter, and so on. This is how we start out. Let's move on to look at our tools. So like I said, we have two turrets, an upper and a lower turret. Just by clicking on one of those tools that I'm using, we're getting our tool palette. So here we have our milling tools, and down here we have our turning tools, and this gives you right away an idea, or the idea, that we can do milling and turning within the same version of Gibbs, or the same module, if you want to call it. So we can do milling and turning, programming it any way we want at any time. So here we are looking at a turning tool, 55-degree insert. Further down, we have a couple of other ones. It's a 35-degree. So this is basically what we tell the system and select our tools. We have some mills. So this is doing some milling at some point on the part. And then maybe do the center drill. This is the center drill that we basically drill the front hole for our tailstock to support the part. So basically we give it the different sizes of inserts, drills, and so on. And of course we have to tell it, are we on the upper turret? Yes or no? Or if we are, okay, let's say like upper turret, okay, then position, what turret position are we in? In this case, this machine has 12 positions in total. So we have to tell it which position we chose. And then this is something detailed about a specific tool holder. Let's move on to my lower turret. This are the lower turret tools, again a 55 degree, then a 35 for finishing, and another one for more finishing, and a little cross drill where I can basically cross drill my hole. These holes that we actually have over here in the flats. So this is talking about our tools. We can select as many tools as we want, or as many tools as the machine has. Of course, here we are limited with ever tool stations the turrets have. 12 on each turret. That's the limit on this machine. With that said, let's go and have a look a little bit at our operations that I already created. Like I said, we have a wireframe and we have also a solid. So GibbsCAM can machine on any machine, okay, with either solids like that, or with wireframe like what you see here. Either way is fine. Okay, and let's just pull up an operation. In this case, it's drilling our center hole in the front of the part. Then we have a couple of other operations. For example, this operation here is turning my OD, or outside diameter. And this brings me now to a feature in GibbsCAM MTM that we call Sync Manager. Since we have an upper turret and a lower turret, so we need to make sure that we are machining those, using those upper turret and lower turret, okay, at times where we don't crash into each other. So over here, once we created our operations, in this case like the pinch turning operation, it puts automatically that operation into our operation list on the right, and this is a typical GibbsCAM feature. Let's look at our sync control, since I just mentioned it. So our sync control or sync manager is basically what we see here on the left. It's the same thing what we see in our sync manager. If I click on it, we're a little bit too far down, there we go. And any of those operations, as you can see, they correlate with our operations in our sync manager. Now, as you can see, we have two flows. We call these flows because it's a flow of operations. So the left flow is for the upper turret. The right flow is for the lower turret down here. So as you can see, we already have these operations next to each other, and I can see them how they work either together, like in this case, for our pinch turning, or if they work separately, or for example, when I'm turning or drilling, in this particular case, my center drill, and then we have a couple of other operations. This one, for example, is positioning my tailstock. Like I said, we have a tailstock in this machine, and once I drill the hole, I want to drill and position my tailstock right here in front of the part. Position tailstock, and then the next one, if I click on that, is tailstock in. That brings my tailstock or my quill, better said, into my part. So I'm supporting now when I'm doing my machining. Now, since we're talking about this, what we're having here is what we call utility operations. And utility operations in GibbsCAM or MTM are operations like, if I just drop this down, like load spindle, unload spindle, or if I have a sub spindle on the machine, then I would program it with the sub spindle in and sub spindle return. So utility operations are all the operations where we don't do any cutting, but we have to move something around, like a spindle or a tailstock, or like you see a parts catcher, there's a tailstock. If we have an indexer, there's certain other things that certain machines might need. Um, Steady rests. So pretty much all of those utility operations or other non-cutting operations that the machine may be able to do. With that said, let's have another look again at our machining again. I'm opening up my machine simulation again. Unzoom. And we have again a closer look at our machine simulation one more time. And then I'm going to go back to and tell you how I can synchronize things up. Again, lower turret was waiting until the upper turret is ready and the tailstock is in, so they can machine together for our pinch turning operation. So we also, of course, you can see now, you see different colors. You can set the system to give us different colors either per tool or per operation. So you see this one, the lighter color. Now the lower turret is waiting until he can go, and it tells the upper turret to do and work together. And these waiting for each other we also call like sync modes or wait codes. Okay. And what you see here, when I'm going over back again to my sync manager. Let's stop our simulation for a second. What we see here in our sync manager, we see some lines going across from one flow to the other, a black one here and a blue one down here, and the blue one down there. Those are our sync codes or wait codes. And we can sync them up as easy and as often as we want to or need to. And often the most important thing is that our operations and our machine runs safe. And this is what we mostly use our sync codes for, or our wait codes. And what I have just done, I just arbitrarily basically clicked on some of my operations on the bottom, on the top, and I'm putting another wait code in. So basically I told now the system, hey, this operation waits until this operation with the lower turret is finished. And the same again, this operation waits until that turning operation on the upper turret is finished. So sometimes I do work together, sometimes I have to make one wait for the other one to be done. Okay, so I simply by that inserted a wait code or sync codes as I need them or I think there should be used. Now, with that said, I see now all the operations as they are, and I see gaps, and they all have the same size of tiles. Let's go and switch to uniform view. So now we have a different view, and I see now every single operation as we have it in the time, or as long as do take, for example, for our pinch turning operation, it roughly takes about 35, 40 seconds. So 55, yeah, something like that, to a minute and 35. So I can see how long each operation take and where we have gaps where the other turret is maybe sitting there and doing nothing. So I can now see how those operations overlap or work together at the same time. And at the very end, I then can also see how long the whole part takes. My cycle time of the whole part, in this particular case, it takes 3 minutes and 50 seconds. So this is a very quick, very easy, using our sync control manager to synchronize our turrets that are able to work together at the same time or separately, or one on the main spindle or one on the sub spindle. Either way is fine. All right, let's switch over to another part. What do we have? I want to go to a little bit more a complex part, which shows us a machine with 3 turrets. And basically it works the same way, different part of course. This particular one has 3 turrets. It has an upper turret on the left and an upper turret on the right side, and a lower turret that can work on either spindle. The upper left can only work on the main spindle, the upper right only can work on the sub spindle, and the turret on the lower side can go either way in between the spindles. The synchronization works exactly the same way I have shown you, but we have the 3 turrets. Now that means we need 3 of those flows, 1 for each turret, and you see a lot more of those blue lines, the user syncs that have been used at the beginning or at the end of any operations, just making sure that they are working nice and smooth together without collision or interference. Let me run this real quick and then we move on to another part. Let's close this. So here we see the upper turret and the lower turret are working at the same spindle on the left, and the upper on the right is working on the sub spindle side. So this type of configuration in MTM is for a very high production type machining, for like mass production of parts where we have basically a cycle time that's very efficient. We do a lot of machining on it. You can see a little bit the details on it. And this one, we're machining on the main spindle. We are milling pocket with the upper and the lower turret simultaneously, while the turret on the top right is machining away on the sub spindle side. So very efficient way of programming this part. Okay, this particular machine, of course, has a sub spindle, as I mentioned, and it will come in pretty soon. And we cut off the part, and when we are ready to move on. And I'm slowing this down a little bit, okay, so we can see a little bit better what's going on. Sub spindle comes in, pulls out the part for a new part, cuts it off, and then we send it home. And we're ready for a new part. So this is a more complex machine. I show you one more, and then we may answer some of your questions that you guys have hopefully sent me in that I am able hopefully to answer. All right, one more machine, and this is going to be a machine, it's called the bone screw. And when we are talking about bone screws, these are typically parts that are machined on a Swiss style machine. Bone screws go into, like it says, into bones of human bones and bodies, and of course animals sometimes as well. But we're not going to talk about this. I just want to talk about which machine we are using about and how we program it. And this is now the thread that we see on this bone screw is typically done with what we call thread whirling. Let's go machine simulation. And here we have the machine that we're going to be using. It's a Citizen M32, and it's a very simplified simulation. Since we don't need all the sheet metals around the machine or the covers, enclosures, and so on, they only obstruct our view. So we basically, in this particular case, said, okay, just show us what's really going on the machine and that has any potential of collision. So here are the split welding heads. I'm going to run the part again so we can see it a little bit more detailed, where we can see through our machine components and holders. But what you can see here, we machining that bone screw, and it's a Swiss style machine, which means we are using a guide bushing. And we come in with a sub spindle, cut it off, and we're done with one side of with the first part. Now I'm just turning it around a little bit to see everything a little bit from the other side. Do a rewind, and then we do it one more time. Now we have a little feature that actually is, oops, that's not what I wanted. This is the what I want. Okay, so we can see through our machine components to make them transparent so we can see better what's really going on the part. This is just a nice little visual feature that helps us get much better view of our part. So real quick, one more time, our machine manager, that's not machine manager, sync control manager, and here we go again. We have 3 flows and we are synced up. Some of you users may actually even recognize, okay, our citizen modes, the 600 codes in this particular case, which is very specific to the citizens and the Mianos. But with all that said, okay, so I want to leave it that way, and I want to open up to some of your questions you may have.